We're going to go over the binomial distribution and how to calculate probabilities in the DCMP data analysis tool. So first off, when we are doing binomials, we have to first consider the three conditions. Number one, are we considering a fixed number of independent trials with the same procedure? Number two, does each trial have two possible outcomes, which we will call success and failure? And number three, does the probability of success stay the same for each trial? If these conditions hold true, then we can use binomial distribution. So for our question, we have an allergy medication was found to be effective in 72% of participants during clinical trials. In a group of 25 individuals, we first want to know what is the probability that the medication was effective for exactly 13 individuals. So first we need to see if this scenario follows binomial distribution. So first, is there a fixed number of trials? It tells us that there's 25 individuals, no more, no less, so that is our fixed number of trials. Number two, does each trial have two possible outcomes? So either the allergy medication was effective or it was not effective. So we have two options, so passes number two. And then number three, does the probability of success stay the same for each trial? It says it was effective 72%. So that's going to be the same each time. So it follows our three conditions, meaning we can use the binomial distribution. So let's go over to our app. And what we want to choose is we want to go down, all the way down to distributions. And we want to choose this one called the binomial distribution. And once you get here, you want to click on Find Probabilities. So you can see it wants us to get our number of trials, our successes, the type of probability, so which direction we're going, and then our value for x. So let's go ahead and write these down in this situation. So first, our n is going to be the number of trials, which we have 25 total trials, total people, so that's going to be our n. Our p is going to be that percent changed to decimal form, so move the decimal over twice to the left to get 0.72. And then our x value is going to be what our question is asking. So this one will change based on the ABC. And this one says exactly 13. So whenever we say exactly, that means equals, and then we have 13. So we can go ahead and put these in, 25 for our trials, and then it was 0.72 for P. And then our X was equals, so we'll keep that as equals, and 13. And once we put all those in, you can see the probability here is 0.0169. So the probability that the medication was effective for exactly 13 individuals is 0.0169. If we wanted to change this to a percent, this would be 1.69% chance that it would be effective for exactly 13. Now sometimes we want to see less than or greater than. This one we have at most. At most would mean less than or equal to, because it can be anything up to 13. So less than or equal to 13. So we're just going to change this to less than or equal to, and that will give our percent. You can also look at the table, and this will show us all of our different probabilities. So you can see how these are highlighted, everything less than 13, which you can see also in the picture up here. So all the ones under 13 will get the dark orange. And you can see there's spaces between these because these ones can only be whole numbers. So you can only have 13 successes, which means you couldn't have 12 and a half people who had allergies because that doesn't make sense. So it has to be exactly 12 or exactly 13 who the allergy medication was effective for. So this will be our answer. Which again, if we want to do it percent form, 2.64%. And then our last one says the manufacturer claims the medication will work for at least 23 individuals. So let's do at least 23. So at least, that's going to be greater than or equal to. So greater than or equal to 23. So now you can see just these ones here are going to be the highlighted ones. So what this is doing is it'll add these three together, and we get our 0.0152. So this gives us 0.0152, which is about 1.52%. So is this result likely? No, this result would not be likely because it is less than 5%. Remember, if it's less than 5%, we consider it unusual, not likely. So that means their claim is unlikely. So that is how you do these in binomial distribution. The only other thing you need to know is sometimes it'll say less than or equal than or greater than. You can see these ones don't have less than or greater than. They only have the greater than or equal to. But what that means is less than 13 is the same as less than or equal to 12, because these are all whole numbers. So if we look on this chart, less than 13 would be all of these ones, which would be the same as less than or equal to 12. So just remember that when it doesn't have that equal sign, just go down to the next number. Same thing with greater than. Greater than 14 would be the same thing as greater than or equal to 13. So just make sure you're doing 15. So greater than 14 would mean it's greater than or equal to 15. So less than, go down one, greater than, go up one, and that should give you the correct answers for those.